Okay, a brief description of ionic compounds. Ionic compounds are created when one atom loses an electron to another atom. Here we see in the top right corner an atom that needs one electron and an atom that needs to lose one valence electron. The transfer of an atom creates ions which then come together to form ionic compounds. You can see their slightly more macroscopic image right here, where you end up with this crystal lattice structure of alternating ions of positive and negative charges. It can be seen in several different ways here. So ionic compounds are always composed of a metal, which loses electrons, and a nonmetal, which gains electrons. Or it contains a polyatomic ion. Compounds of ionic properties, they exist as solids at room temperature. Most of them are white solids. Okay, and they can be dissolved in water, at least to some extent. Okay, when they dissolve in water, the positive and negative ions separate from each other. Okay. If you take an ionic compound dissolved in water and evaporate the water away, often you will be left with a crystal formed by the recombining of the oppositely charged ions. This is an illustration showing why and how ions dissolve in water, ionic compounds dissolve in water. Water molecules are polar. They have a part that is slightly positive and a part that is slightly negative. The slightly positive part of the water molecule will interact with a negative ion, drawing it towards itself, and the slightly negative side of the water molecule will interact with the positive ions, pulling them away and essentially surrounding the ions with water molecules. This is what causes the dissolving process. Ionic compounds, we can determine their formulas by looking at the number of valence electrons. For example, magnesium has 2 valence electrons, oxygen has 6. It needs to have a full outer shell or a stable full orbital. And so it will pull 2 electrons from the magnesium atom, leaving behind a magnesium 2+ ion and an oxygen 2- ion. And these will then stick together in a ratio that cancels out the charges. So 1 Mg and 1 O. So the formula forms MgO. Sodium chloride, similarly, the sodium loses its 1 valence electron to chlorine, which needs 1. So we get +1 and -1 ions, which stick together in a 1-to-1 ratio to form sodium chloride, NaCl. Magnesium and chlorine will react in a different ratio because magnesium has 2 electrons to give up or to lose, whereas chlorine only needs 1. And so 2 chlorines will each take an electron from the magnesium. So what you end up with is 2 -1 chloride ions interacting with 1 magnesium 2+ ion. So for every 1 magnesium, you'll need 2 chlorides. So we get the formula or the ratio of reacting ions to be MgCl2. On the right are shown a bunch of more examples showing how you can find the formulas if you are working with ionic compounds containing polyatomic ions. It's the same idea. The polyatomic ion has a charge. In this case, nitrate has a 1- charge. So you will need 2 of them to interact with a calcium 2+ ion. You can use the crossing method where the 2 from one becomes the subscript for the other, and in this case the -1 becomes a subscript for calcium, so you end up with calcium nitrate 2. Okay, the end.